Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 17, 2025, which was about 6 days ago. The standout result is that the smaller GPT-OSS 20B repeatedly beats the larger GPT-OSS 120B on key benchmarks like MMLU at 69% versus 66% and PsyQ at 87% versus 82%. The paper is titled, "Is GPT-OSS Good?" A comprehensive evaluation of OpenAI's latest open-source models, and the implications for model training are quite significant. Beyond that, the study finds mid-tier overall performance, stronger code generation, weaker multilingual capability, and notably better efficiency for the 20B model. Building on that, the tweets highlight the 20B model outperforming 120B on MMLU and PsyQ, discuss sparse scaling limits, request broader comparisons, and show moderate engagement around 100 likes. Alright, we are looking at a radar chart that compares 8 models across 10 benchmarks, so you can see strengths and weaknesses in one view. The highlighted red and orange traces represent GPT-OSS 120B and GPT-OSS 20B, which form a mid-sized polygon overall. The polygon for GPT-OSS 20B reaches farther on MMLU and PsyQ, indicating better scores there. Meanwhile, both traces pull inward on HumanEval, signaling weaker multilingual performance compared with others. Now we are looking at a summary table that lists the 8 evaluated models, separating mixture of experts from dense designs. You can see parameters in billions, size in gigabytes, and the architecture label, which together set the resource footprint. The key detail is the active parameters note. It shows how a mixture of experts only use a subset per token. So GPT-OSS 20B runs with about 3.6 billion active, while 120B uses about 5.1 billion. That difference helps explain the 20B efficiency advantage we discussed earlier. Okay, we are looking at a scatter plot that maps model size on the x-axis against average accuracy on the y-axis, so you can see how capability changes with parameters. The orange squares mark the GPT-OSS models, with 20B sitting higher than 120B despite being smaller, which reinforces the inverse scaling point. The background bands label performance ranges as good, fair, and bad, giving quick context. You can also see several blue peers clustering near 70 to 90% at larger sizes, underscoring the mid-tier placement we discussed. Now we are looking at the overall performance table, which summarizes 10 benchmarks for 8 models and reports an average column at the end. You can see QN 3235B leading the row, while the 2 grams PT-OSS rows sit in the mid-tier, with 20B above 120B on MMLU and PsyQ, so the inverse scaling pattern holds. The colored cells mark first, second, and third per benchmark, which shows stronger code generation, but weaker HumanEval scores. Together, these columns reinforce the earlier efficiency and capability trade-offs. Now we are looking at a grouped bar chart that compares accuracies across 10 benchmarks, so you can see where each model leads or lags. You can see orange bars for the 20B model and blue bars for the 120B model, with values printed on top. The 20B bars edge ahead on MMLU and PsyQ, while the 120B bars are higher on FinQ and PIQA. Both bars drop sharply on HumanEval, which reinforces the multilingual weakness we mentioned earlier. Continuing from the bars, 2 takeaways stand out. The 20B mixture of experts model reliably beats the 120B sibling on key benchmarks while using far less energy, and sparse scaling alone does not guarantee gains. Mixture of experts means only a few expert networks activate per token, boosting efficiency. That is it for the AI Research Roundup. I am Alex. Thanks for listening.